So in this lecture, we are going to go over calculations for standard deviation. So how to calculate standard deviation. So this is more like the math behind standard deviation. For the concept of standard deviation, check out the other video. So we know that this is the formula for standard deviation. S is represented as standard deviation for sample. And there is like sigma, which is represented as standard deviation for the population. But in this lecture, we are going to cover how to calculate standard deviation for sample S. And there is a formula given here, which is square root of 1 upon n minus 1 summation xi minus x bar, the entire term squared. And these terms are summed up, as you can see by the sign of summation, which goes from summation index of 1. So I is nothing but index, summation index, which goes from 1 till n, whatever the total data points you have. So you have to calculate that each data point, each x value, and the difference from the mean, because standard deviation concept means you're calculating actually the variability around the mean. That's why you want to get that distance. Just check out the concept video for more clear picture of the concepts. So let's look at this example. In this example, we have given some x scores. Maybe this is some kind of scores. So just look at that and then write down that in a column fashion. So if you follow this process, it's going to be more systematic. It's very less likely that you're going to get a wrong answer. So this lecture is more focused on hand calculations. That's why it's very necessary to go in a stepwise manner. So we have given these data. So this is given to us in a question stem or in your research. So let's see what are the values. So let's say these are some measurements you have, and first measurement is this 1792, second is this, third is this, fourth, fifth, sixth, and seventh. So right away you know that you have 7 different data points, right? So your n in this case becomes 7, because n is nothing but the total number of data points or the individuals in your data set. So now you know the n. What other terms you need to know? Let's look at this. So you also need to know the mean. So these are the mean for x values, and you have these x values here. So you just need to calculate the mean, and the formula for calculating mean is x bar, which is summation of all the xi's, those are individual x values, it should be xi's, upon n, that is total number of values. So basically what it means is you just have to add all these numbers together. So 1792 plus 1666 plus 1362 plus 16414 plus 1460 plus 1867 plus the final data points, which is 1439. And once you get that sum, just divide that by n, and n in this case is nothing but 7, because you have 1 2 3 4 5 6 7 data points. So you know the n is 7. Once you know this sum, just divide that sum by 7, and you should be able to get x value, x bar value, as somewhere around 1600. So I'm not going to go over detailed calculations because I think it's pretty simple for calculating mean. That is simply adding these numbers, dividing by the total number of these. How many data points are these? Um, so now you also know the x bar. So the only term remains unknown is xi here. Now what does that mean? Those means the individual x values in your data sets. So all these. So you have to consider each of these data point in calculating this term. However, we are going to do it. So let's break it into steps and go for that. So Let me write the steps before we go on here. So as we see, we just need to find what is given in our data set first, and then we need to understand what we have been asked to calculate. So in this case, we have been asked to calculate standard deviation for this sample. So the first step in here is to calculate the mean for mean for the data, that is x bar sample, and we already completed that step. So next step is to calculate these deviations from the mean, that is xi minus x bar. Note that this is not exactly same as this, because this term is the squared terms, which we are going to do in later step. So second step is subtracting each of these x values from the mean of those x values. And then the third step becomes squaring those deviations. So basically squaring this answer here. So that's how we are going to get these terms. And then we know that we have to sum them up from for all the values. So from all first till the nth data point. So that is why your fourth step becomes here summation of all this squared deviation. And then the final step becomes, so basically we are solving this formula in a stepwise manner. So now you know this entire thing. So only thing left is dividing that entire summation with by n minus 1 and taking the square root. So you can consider it as the same step, or you can also split it as a different step. So step fifth is sum divided by n minus 1, which is by the way nothing but degrees of freedom. And then in the end, taking the square root of that entire term that you have calculated. So let's go over. So let me just clean these things. All right. So you know the n is 7. You know each of these x values. So just find the difference. xi. So in this case, your first I, instead of I here, it's the first x. So that means your first term becomes x1 minus x bar. X1 in this case is 1792 minus x bar is 1600. So 1600. And then you're going to get solve that math. Similarly, then you're going to go do x2 minus x bar. Your x2 is in this case is 1666, so it's going to be 1666 minus 1600, so on for all the other x values. So 1362 minus 600. So notice that in this case you're going to get a negative value. That means that this particular data is on the negative side of from the mean, right? Then proceed with the other x values. This is for x4, for x5, for x6, for x7, all right. So now if you do the simple subtraction here, you're going to get subtraction. You get answer as 195, 1792 minus 1600, 166 minus 1666. Here you're going to get the negative value, 14, 16, 14 minus 1600, negative 140, 1867 minus 1600 is 267, and 1439 minus 600 is negative 16. So once you get these terms as deviations, you have completed step 2. Now there is a method that you can verify whether you are going correctly, is by adding all these deviations and looking at the sum. If the sum is 0, that means it's correct, because that means your you have equal number of data points on either side of the mean, right? So that's like the another method of cross checking whether you're proceeding in a right direction. Otherwise you can just stop here, go back and do the calculations again. If everything seems right, sum is 0, then proceed with the next step. And next step is nothing but squaring these terms. So basically take the squares of this. So 192 square, then 66 square, then negative 238 square, 14 square, and so on, right? So notice that the negative sign is going to go away, and that is what we want, because we don't, otherwise we are going to end up with getting 0, right? So we want to square them, and if you calculate the square, 192 square is 36,864. 66 is this, square of next term is this, 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 and this. So likewise, you're going to get the sum square for these deviations. So that means you got all these square deviation values. Once you get these, just add them up to get the sum. That is what we need to do here as a summation. So add them up. So that plus 56,000 plus 196 plus 19 plus 71,000 plus 25,000, and once you add them up you are going to get answer as 214,870, right? So basically that sum is represented by this entire term right here. So we have so far solved this entire term. So now what we need to do is just divide this by n minus 1 as the next step. So 214,870 divided by n in this case is 7, because we have 7 data points. So 7 minus 1, that is nothing but 6. So it's going to be 214,870 divided by 6, and if you solve that, it's going to be somewhere around 35,811.7. Now you have solved everything within this, under this square root sign. So basically the last step is to take the square root of that term. So if you take the square root of this as a sixth step, so square root of 35,811.7, you are going to get your final answer as 189.2. That is nothing but your standard deviation for the sample size. Remember that if you don't take the square root, so that means this is your s square. So s square is nothing but variance. It's also called as variance. So if you have been asked to calculate variance, stop right here. If you want to calculate standard deviation, you can stop here, right here, and then describe that standard deviation. So that is standard deviation.